Hello, my name is Eric Fritzinger, the lead developer for the Demeter Framework prototype. Today, I'm going to run you through a typical usage of the framework and its supporting components. What you see before you is the Persephone user interface. It has been developed in the Microsoft Silverlight framework and provides a means of utilizing the various tools that Demeter has to offer. In the center here is the scenario canvas, where I will place and configure both activities and channels. Over here to the left is a list of the activities currently available for use in a scenario. The activities listed here at present are the default activities, as defined by the online catalog, which I will talk about later. These activities provide simple input and output in the scenario. Also grouped with the activity list is a file transfers list, which will contain all of the files waiting to be downloaded to the local system, and a trace pane for runtime output and debugging. At the top of the screen is the ribbon menu, a menu paradigm made popular by products such as Hydro Desktop and Microsoft Office. There are currently 3 tabs: Home, Runtime, and View. The Home tab is going to typically be used for edit time interactions, whereas the Runtime tab contains the runtime controls such as start, pause, and stop. So now let's manage our registry. As you can see, the registry contains the list of available components, as well as the libraries needed by the components. I can browse the online catalog, load a pre-created package, or I can create my own by manually adding the libraries to be inspected. In this particular instance, I want to add a DotSpatial tool called Clip Raster Layer that is currently registered with our online catalog. So I click this button and begin my search. Going to this drop-down menu, I select Activities. This will query our servers and provide a list of activities present in our catalog. Once this appears, I will now select Clip Raster Layer and add it to the list of components that I want. Now, I click OK, and the system here will request and download all of the necessary libraries and files that Clip Raster Layer requires, including all of the libraries and files for the translator that the activity requires. In addition, during the request, it will also search for and download all other immediately associated activities and files. For instance, if there are other translators, activities, or data format converters that are defined in any of the libraries being downloaded, they too will be added to the registry. Once it has completed downloading, the components downloaded will appear in the registry. So now I can click OK, and they will be added to the activity library pane on the left in their own group here. Now I select the scenario canvas that I want to add the activity to, thus highlighting it. And I click on Clip Raster Layer to add it to the canvas. Once here, it can be moved around via click and drag. As you can see, the activity has small ports on either side, referring to the input parameters over here and the output parameters over here. Now I need to provide this activity with some input. So since the activity takes files for input, I can put down 2 open files activities. One of them I will add a raster by double-clicking the activity, thus bringing up the configuration window. I will browse to the raster I wish to use and open it. I click OK, and then now the file is embedded in the project. I will open a shape file for the other open files activity. Since shape files have the context of several associated files, I will include all of them for this activity, and click OK. Now, to connect the input data, I simply click a port on one activity and click the port on another. This creates a channel between the 2 ports and allows the data flowing out of the output port, in this case the open files activity, to be received by the input port, and in this case the input port of the Clip Raster Layer activity. The window that pops up is the channel configuration window. It allows me to see the properties of the 2 ports being connected, as well as a list of the available data format converter paths. By default, no data conversion is selected, Since I don't want to convert any of the data before it reaches the activity, I can simply click OK or press Enter. We will do the same thing for the other input activity. Now I need to be able to output the data. So I will put down a Save Data activity and connect it to the output port of Clip Raster Layer. Again, I don't want any conversion, so I just click OK. Now I have completed my scenario configuration and I want to run it. So I go to the Runtime tab and I click Start. It will now upload the scenario to the runtime service. Once upload is complete, it will execute the scenario by creating a directory structure in the server's temporary folder and running a scenario runtime executable. The runtime executable will continually communicate the progress of the scenario execution to the runtime service, which will in turn communicate these events with the connected client, in this case, the Persephone Silverlight interface. The controls at the top allow me to pause or stop the execution. However, at the present, the runtime can only pause or stop between activity executions. Once the runtime is complete, and after dismissing the warning that occurred, I can go to the File Transfers pane on the left and see the file that went to my computer. I will now download the file by clicking the Save button, and here you can see the result. You can also save and load scenarios from your local computer as well. Here is a scenario I created earlier, which contains a lot of different activities. The light purple activities up here are web service activities hosted on our servers. The Water OneFlow activity down here provides a user interface for searching Water OneFlow web services for data. The NCCP data search activity here incorporates a user interface to search the NCCP data portal for data. I am going to run this and talk about some of the future enhancements I have planned. At the moment, the DotSpatial translator only supports Clip Raster Layer, which is why it is the only DotSpatial tool in the catalog. However, it is being developed and should see an explosion of more available tools. In addition, at this time, the online catalog is closed off in regards to adding new components, at least until a secure method for adding them has been developed. Lastly, I am continually looking for new components to add to the framework, and any input or collaborations would be greatly appreciated. And now it's going to run through the execution of all of these activities. As you can see, the files have been successfully transferred. The trace here from these three trace activities, you see the mean, the median, and the standard deviation as supplied by these activities. That concludes the demonstration of the Demeter Framework and the Persephone user interface. Thank you for your time.